Welcome back, unless you're new. And then in that case, this is Full Stack with Lawrence, and I am Lawrence, and I'm a full stack developer, and so it all makes sense. This is video 2 of a 3-part series, and so if you missed the first part, look somewhere on the screen and YouTube, and you'll see how to get to video 1. Video 1's great. It shows you how to build the cluster that we're about to look at right this second. Let's get right into it. Actually, first, let's roll it. All right, that was cool. Now let's get into it. I didn't really talk very much about this awesome piece of software called K9s. I installed this is a Mac, and I installed this using Homebrew, and that incidentally works with Linux and Mac OS. Can't really speak for Windows. It's a pretty simple install, K9s. There they are. You can see I've been here before. So what it is it's just a GUI that runs on top of kube control. And so anything that you can do with kube control can be done here. It's just easier. And so I've got, like dozen things that I'm constantly looking at with kube control, and they're all just hotkeys using K9s. So I really love it. And so, like, for example, to switch my namespace and get all the namespaces open, it just took like 3 keystrokes. And that's a lot better than trying to do it all on the command line. And then even when you do it on the command line, it's hard to read and it's hard to control the output. So all that stuff is done for you here. And so, true to my word, we really did go directly from video 1 to video 2. This cluster has been up for a grand total of 15 minutes. And so I didn't even stop to take a drink of water. That's how important you are to me. All right, so let's do some stuff. First up is I want to take a look at what's going on with the ingresses. We got this ingress here for the software that we've deployed. As a review, hopefully you saw video 1, but if you hadn't, then here we go. Here in the deployments, we deployed cert-manager, the Nginx ingress controller. There's competing solutions for that, by the way, and this is probably a good topic for another video. Karpenter, that helps us with the management of nodes, and then we've got a couple of EKS add-ons that have component software that belongs on the nodes themselves. That's what you see there. Metrics Server and Prometheus kind of work hand in glove with each other to provide data to the virtual Pod Autoscaler to tune up the pods and make sure that none of them are consuming too much or too little of the CPU and memory resources that they need. Okay, but what we really wanted to know was how to get logged in to Grafana. Grafana was installed with a Helm package, and so I'm going to, I guess, take this opportunity to show you what that means in practice. And so to do that, I'm going to pop open the code repository itself. And this, I guess technically this should have been part of video 1, but I wanted to keep video 1 nice and tight and to the point. So in Terraform, if you're newish to Terraform, the way it works is that any file that's got a TF extension, all the files are in that folder are just kind of, from the perspective of Terraform, they're just lumped together, and it just runs whatever the Terraform code is and all these collectively. And so the fact that Terraform is broken out in multiple files, that's actually just kind of a stylistic choice of whoever wrote it. So I wrote these, and there's some industry best practices for what to name these and what to put in them. And so, kind of as intuition would have it, all the variable declarations are here. This you definitely want to know about. This is how you can initialize all the variables without having to kind of respond to a command line interactive session with Terraform to answer the questions. What account ID do you want? What AWS region do you want? You can just put all that together in this file that has a very specific name. It needs to be exactly named terraform.tfvars. So that's this one. The next one, ditto. Terraform.tf is where the Terraform configuration exists. And so you must, if you made it this far and you're following along with me, then you got in here and you edited a couple of things in here to get it working. If you haven't followed along with me, be aware that you need to do that. Providers, as the name would suggest, providers are the extensibility model for Terraform, and so some great examples of that. The best example is AWS itself. And so this right here is what is providing the Amazon Web Services command line interface parameters for everything that Terraform needs to do with Amazon. Ditto for when Terraform needs to interact with the Kubernetes cluster. And it needs to do that, for example, when applying a Helm chart to install software on the Kubernetes cluster. And sometimes it's doing that using kube control instead of direct connections to Kubernetes. There's that. Helm itself needs a provider. And so the things that are kind of Kubernetes specific, there's 3 different providers that are being described here in this, I'll call it the parent folder. And just know that those providers kind of trickle down to anything that's being called from here. The actual code that we're executing, here it is. It's kind of weird we see EKS. Oh yeah, well, it's a misnomer. So this should be called probably stack or something like that, because this actually builds the VPC and the EKS Kubernetes cluster. But here's all the variables we're going to pass into one or both of those 2. And then we've got these miscellaneous other things that we're going to execute. The vertical pod autoscaler, cert-manager, and so on and so forth. We can see this consistent pattern in each one of these, where this module that we're declaring doesn't really have any Terraform in it at all. Instead, it's got this source declaration that points to this path. This path is like, here's the current folder location, and then modules, that would be this right here. And then it's looking for Kubernetes cert-manager, that would be this right here. And so this is the actual code that gets called, and that has stylistically kind of the same setup, except that when you go into this, there's real stuff that's happening. The thing that's going to be common, I'm going to jump back to all about me again. The thing that is common, that is noteworthy, that you want to be aware of inside of these Terraform modules, is that with the exception of the creation of the VPC and EKS, every other thing, what it's doing is interacting with a Helm chart. And so what you're going to see is this basic consistent pattern for queuing up this Helm chart, this version of the Helm chart, and then here's the location of the parameter file for configuring the Helm chart, and then boom, go. And so now back, I want to show you, using cert-manager as an arbitrary example, what that looks like in practice. And here it is. So not a lot to look at. There's just like a dozen, not even a dozen, like 10 lines of code there. But that's the thing that gets cert-manager installed and up and running. So like, don't underestimate how important those 10 lines are. You'll see that there's a thing called values in here. These are hooks that I've created just for you. So if you trace this backwards, what you'll see is that ultimately it's pointing to this thing here, the cert-manager values. And so here's an example of stuff that you can put in here to tune up and customize and personalize how cert-manager works inside of your Kubernetes cluster. And then if you want to know, like, well, Lawrence, where did you find, like, how would I know what to put in here? Let me show you. In the main Terraform module of every one of these, there are copious notes at the very top right here. The most important thing that it's showing you is what Helm stuff has to happen locally on your computer from the command line to get the chart itself locally stored in the local Helm repository so it's going to work. And then beyond that, I'm only going to do this with this one. We've got a way to introspect and discover what's inside of the Helm repository, and that's this Helm search repo. And so in this case, it's going to show us what it's got with regards to cert-manager. I'm going to skip that in the interest of brevity, but I will show you this. Wait, not that. I will show you this. The Helm show values. Let me pop that open here. When I run that command, what it's going to do is it's going to dump every possible parameter for cert-manager. There it is. It's real fast. I cleared the screen so I could do this. I could just like bounce right back up to the top. So this is a YAML formatted file with copious amounts of comments inside of it. That's copious twice in like 2 minutes. And that's a fancy book word. This is everything that can be changed inside of cert-manager. And so the way you found it is by running that command there. And so, effectively, I could just copy and paste everything that just dumped out into the console and put that inside of here. And you would get what you already got, but now you could go through and you could start tinkering around with these values. And so if you want to hack it up, that's how you do it. All right. And so every single one of these modules, except for EKS, that's how it works. And so that's my guidance for you. Godspeed. Good luck with next steps. All right, let's get back into the task at hand, which was to get logged into Grafana. Inside of Kubernetes, there exists such a thing as secrets, and it's just this awesome way to manage passwords. So here's all the secrets for the entire Kubernetes cluster. And what's of interest is the basket of secrets that exists for Prometheus. That's the thing that installed Grafana. And I have found it. There it is right there. And so I'm just kind of just spelunking through here to find this. So there's the secrets that the Prometheus Helm chart had Terraform generate on our behalf to then store inside of the Kubernetes secrets. And so here they are. And so remember, this is not going to work for you. It's going to work for me for about 30 more minutes, and then it's never going to work again. I'm just talking about this password right here. So we have Grafana open here. Here we go. Awesome. And so we just need to know what is the username, which is admin, and what's the password. And I think I'll copy and paste that one because it's a little challenging. This was generated by Terraform, by the way, and so that was spec'd. It was like, we want this many characters and this many special characters or not, and so on and so forth. So that's pretty cool capability that Terraform has. All right, so God willing, I'm gonna hit the login button and it's actually gonna log in. And it did, woohoo! All right, first try. That's awesome. Now, here are the things that are important that I want you to see. So number one is that it's HTTPS, all right? So there's our certificate. So the certificate's valid, and here's what we can see about, I can't see anything because I'm so nearsighted. Let's Encrypt. There it is. All right, issued by Let's Encrypt. That's the key thing. So cert-manager leverages Let's Encrypt. And then there's more stuff. It's a SHA-256. That's cool. And it's all managed. You don't have to do anything to keep that working. So you got that just like right out of the box. And incidentally, you've got the way to continue to duplicate that. And so the way that's going to work, I think, is if I take us over to the Prometheus namespace, then there should be inside of this this certificate request. So this is a good one for you to take a hard look at. I'm going to put it in edit mode. It's like using Vim to open up one of these manifests. And so here's the actual manifest that was used for setting up and queuing up that certificate. And so this is something you want to take a hard look at and familiarize yourself with, what's been placed in here and why does it work. All right, and so that in turn caused this certificate here to be created. And so here's the result of that certificate request, okay? So we saw the certificate request and then the certificate, and then the place where those are married together is the Ingress. And so if we travel to the Ingress for the Prometheus namespace, then here it is. And we're gonna see inside of here a couple of things. We see that it defines this host. And so that's why web traffic for Grafana.fullstackwithlawrence, blah, 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 gets routed into this service here. Well, that's the wrong service, here. So it gets routed to this service on this port. So all that's being described inside of the Ingress. That's kind of item number one. And then item number two is, since it's TLS terminated, we need to define that as well. And so that's also happening. So if it was old school and you spun up, well, I guess you didn't spin up, you installed Nginx, and then you went into a .conf file and opened it up, this is where you would put, here's where the SSL certificate resides on this file system, and here's the traffic that uses it, and if it's HTTP, you're going to redirect to HTTPS. You do all that inside of Nginx. This is the equivalent if you're new to this world. And so a lot of that, actually all of that, is being handled through what's called annotations. I'm going to leave it. That's another story for another time. That's everything I think you need to know for the moment about cert-manager and the fact that it worked and why it worked and how it's going to keep working in the future. All right. Then we saw secrets, and that was all cool. So let's take it to the last topic, and that is changing stuff. And so item number one is I'm gonna make a modification to the range of EC2 instances that we can choose from, and we'll call this, we'll make this one big. So we've got T3 extra large, T3A, T2, and so now we're gonna add one more in there. That's T2 extra large. So we got one more kind of thing we can look for. That should taint the managed node group for Terraform. And so if I run this plan, then I am reasonably certain that it's going to see that, it's going to taint the managed node group, and it's going to need to do some work on that node group. Now, I'm not going to apply this because it would take probably 15 or 20 minutes for it to get through the whole process. Just be forewarned that that's the deal. When making changes, yeah, see that? So the things that are going to get destroyed, it's probably going to destroy the managed node group and recreate it. And what that effectively means, it's going to create a brand new node group, then move the pods over to the new node group and shut down the old one. And that is a lot of heavy lifting. Now, it's highly reliable. I've never run into problems with that kind of stuff, but it's still, I get real anxious when Terraform wants to make changes that are that aggressive. And so what I think I'm going to do is get rid of those changes and then move on to the last part of our exercise. Okay, so that's that. So we're clean again here. Now, some things you need to know. Back to me. Terraform is imperfect. And so there's two ways that it's imperfect that bear mentioning. The first is that it doesn't handle syntax and semantic errors very well. And so when it runs into either, what tends to happen is it generates just massive amounts of ASCII vomit into the console that's just kind of unintelligible console output that oftentimes has just nothing to do with the real problem at hand. And that is all to say that Terraform as a tool is something that you get better at with hands-on experience. And so you need to see those kinds of console responses with your own eyeballs and then let your mind assimilate what it means and what to do about it. And more experience kind of smooths out the bumps and stuff. So that's item number one. And item number two is that what I just showed to you, where I changed some things in Terraform, and then the instance list, the instance type list, it definitely detected that and put together a work plan. That part is imperfect as well. So there's certain things that it will detect and other things that it won't. And one of the things that it won't detect is one of the most important things about Kubernetes, and they have a rational reason for why they ignore it, and that's how many EC2 nodes do you want in a draconian fashion to exist in the Kubernetes cluster right this second. The reason they ignore it, so you could put that, I'm going to go back to the desktop now. Kaboom, here we are. We're in Terraform TFVars, and so towards the bottom here, probably at rock bottom of the list, yeah, here's our variables that I created for us that have to do with the cluster itself. And so we get this triplet of values, the lowest number of worker nodes, the desired, and the maximum. And so that kind of sets the lower bound, the upper bound, and how many you would like right this second. And so what I'm referring to is that one there, the desired number of worker nodes. It ignores that because there's infrastructure in place inside of your account that we deployed as part of this that is actively making that decision on your behalf. And so that's the auto-scaling technology that's inside of the EC2 console. That got created, and so you can't just change this value and then Terraform react to it. And so that's kind of weird, and that's why I'm telling you. And so instead of that, what we can do is this. If I wanted to change the number of nodes, and you may or may not have even seen how many, we're supposed to have 2, and at least that's what we had a second ago. We still do. So here's our 2 nodes. Things are looking good. CPU's not loaded at all. The memory's not loaded at all, so things are looking fantastic. Nonetheless, suppose we wanted 3 instead of 2. Then that is not the kind of thing that would work with Terraform. And so what you would need to do is physically yourself, your person, log into the AWS console, come over here, go to the node group, select it. If we wanted to go from 2 to 3 nodes, here's how we would do that. Is I would ticket up myself inside of the console, save the changes, and then we're going to see the following is going to happen. Right here, actually it bumped us over to this other window tab, and that's kind of weird. It makes sense, but we were here in nodes, and so when we click the save button, it's like, well, you don't need to be there anymore. You need to be over here in the update history, which was where I wanted to take you, but I wanted to do it myself. So let me take you back where we were and show you what's going on over here right now. I don't know why I can't see anything there. So I apologize, I'm clicking on so many things. But I am in the cluster and the managed node group, and we're supposed to see that it is updating. And so I guess that's pending in just a second. And so I don't know, we wait patiently for a second and stare at the screen, and then this is going to switch from active to updating. And then this table here will go from 2 to 3. It's not showing up here in the console, just one of many reasons I don't like the console, but it is showing up in K9S. So there's our third node. And so before the AWS Web Console was even aware of the existence of this, K9S has already detected it, picked it up, shown it, here it is. And so if we jump over to the pods and have a look, then we should be able to see, based on the age of the pods, I can see that this pod here is 43 seconds old. And then if I get all these open at the same time and then I sort the screen by the age of the pod, like so, then I can see that these 4 pods are less than a minute old. And so that is what is running on that brand new server instance thus far. But what will happen, Kubernetes is pretty amazing. It will watch what's going on, and pretty soon it's going to start shaving off pods from this node and scooting them over to this new EC2 instance, this new compute node, because it's underloaded. And so I don't know that it makes sense to sit here and watch that happen, but it will if you want to just borrow my confidence and trust me on it. And on that, why don't we call it quits? And we will pack it up and head on over to video number 3, where we're going to tear all this business down and take it down to 0. All right, and if you like this, there's like the like and subscribe and all that business. It'd be awesome if you did that because it helps a lot. Thank you, and I will see you in the next video.